back to the channel. Today's mini lecture will be on the geologic history of planet Earth, as well as the composition of Earth's atmosphere. Both topics will be included on the AP exam. They are included within one of the units that's going to be tested, so this will be very helpful in preparing for that exam. So let's get right to it. So as we look at this image of the Earth and starting at a time period of a little bit over 700 million years ago, as we come through the Precambrian, I remember at this time there was really no organized life other than bacteria. Here we have the Cambrian explosion entering into the Paleozoic. An explosion of life that has never been seen before on the planet, more biodiversity than ever. Throughout each of these stages, you have mass extinctions, but the biggest one comes up about right here at the end Permian. That was the day that about 90% of the planet died. The Mesozoic, that's the age of the dinosaurs. And again, you know what happened at about 65 million years ago? Big space rock comes in, smacks into the planet, no more dinosaurs. It ushers into the age of birds and the age of mammals. And now you see the present day alignment of the continents moved about by those forces we talked about, plate tectonics. So what powers every other process on planet Earth? Only one thing, this unshielded nuclear fusion reactor called the sun. It, from 93 million miles away, gives us the heat that we need through solar radiation, provides the energy for every biogeochemical cycle that we've talked about, is the main influencer of climate along with tilt and distance from the equator, is the main source of weather, temperature differences. And with those temperature differences, you have the generation of wind. Again, that's also going to be affected by air masses, low and high pressure, all again influenced by this beast, the sun. Now keep in mind the sun is providing the full light spectrum from ultraviolet all the way to infrared, the infrared being how we deliver heat. And as we think about the heat, albedo becomes a major influencer on the retention or dissipation of heat. If you look at the definition of albedo, it's the proportional reflectance, how much it reflects. And this proportion is set up as a percentage of the total amount of heat coming in as solar radiation from the sun. So when you're thinking of ice, solar ice caps, glaciers, they're reflecting 80 to 90% of the heat coming from the sun. When you think of open ocean, asphalt, dark colored material, now instead of reflecting 80 to 90%, you are absorbing 80 to 90%. Now, if you look at the graphic there of the planet Earth, you can see the blue areas. Well, guess what? That's where the heat is being absorbed, and the areas up at the north and south poles, those are the areas where you have the most reflectivity. So what does that mean to the overall total climate? If you're looking at more ice, you're looking at less heat retained, more heat dissipated, lower temperatures. If you're looking at less ice, you're looking at more heat retained, higher temperatures, less heat dissipated. And we all know what's happening to the ice. It is all melting. And with that in mind, it doesn't take long to see where this heads. The less ice we have, the less heat we dissipate. The hotter it gets, the more ice melts. You see what the pattern turns into. And as oceans continue to absorb more and more heat, they continue to become warmer and warmer, which that heat circulates through planet Earth, and it is melting the ice at the poles. Less ice, more heat, less reflectivity. If you really think about it, the albedos of open ocean and ice are exact opposites. Furthermore, when you think about heat delivery from the sun, we also have to consider the angle of incidence, or the actual angle that the solar radiation is striking the Earth, and that is greatly influenced by the tilt of the Earth and the position of the Earth around the Sun. In the next couple of graphics, we'll take a look at that, and hopefully that will clear up some of those ideas for you. So this graphic is just basically showing you the Earth's path around the sun, and because of the tilt that the Earth has on its axis, we do experience seasons. An increase of warming, a less warm time in winter, the spring and autumnal equinox, the vernal and then autumnal equinox, where day and night are the same periods of time. Again, all based because of the axis being tilted. Now, with that axis being tilted, this is how we get the uneven heating. You'll notice that the less direct heat is going to be less heat delivered. Notice the angle in the northern hemisphere. It's a much lower angle. And because of this lower angle and the tilt of the Earth, you can easily see that that would be during our winter time, whereas in the southern hemisphere, that's going to be summer. So the next topic for consideration would be the composition of Earth's atmosphere. So we'll be taking a look at each of those layers and determining what their characteristics are. Let's get right to it. So as illustrated in this graphic, you can see the different layers of the atmosphere working outward from the surface. You are in the troposphere, again, where all life is and weather. Next layer out is the stratosphere, home to the ozone layer. Keep going out, you reach the mesosphere. That is where our meteors burn up. And then finally, the last layer that you will need to be concerned about is the thermosphere, home to the International Space Station and the aurora borealis. Each of these layers of the atmosphere have their own unique characteristics, and let's take a dive into what these characteristics are. So the troposphere, the area closest to the Earth, is only about 8 miles thick. That would be where all the breathable oxygen exists. That's where all of our weather exists. That is where all of our pollution that we make, all of our air pollution exists. Um, as we travel up into the troposphere, the temperature is going to decrease. So it's pretty simple. Temperature decreases with an increase in height, and there is an actual approximate formula to determine how much temperature difference would it be from sea level to an elevation. It's about -6 degrees Celsius or 11 degrees Fahrenheit for every kilometer in elevation increase. And because this layer of the atmosphere is so thin, it is so easy to change through influences such as human influences or natural influences. The next layer out would be the stratosphere. The stratosphere is famous for containing the ozone layer. There is a very powerful wind that separates or actually lives right at the base of the stratosphere. It is called the jet stream. Very little water. It's about 30 miles thick, about twice as thick as the troposphere. And then again, as I go up in altitude, the temperature actually increases. Next out is the mesosphere. The mesosphere is very, very thick. Again, it is famous for burning up any space debris that comes towards our planet. And again, this has a different temperature gradient. It is very dense. That's the reason why entering material burns up. However, if you start to travel outward, the temperature will drop dramatically. Next layer out is the thermosphere. This is the largest of the layers, the most thick of all the layers, and surprisingly, it is very, very hot, but that is due to X-ray radiation and shortwave radiation. You can have temperatures in excess of 1,000 degrees Celsius. A thermosphere is also home to the aurora borealis, or the northern lights. It also happens in the southern hemisphere, but that is caused by the thermosphere absorbing the radiation from the sun in ions, almost electrifying it. And so you see these colorful waves dance across the sky, and that's actually radiation that is being captured and pulled to the poles in the thermosphere. So that concludes this mini lecture on Earth's geologic history, as well as the influence of the sun on climate and albedo, and as well as the different layers of the atmosphere and the characteristics that they have. If you have any further questions about any of this content, of course, you can always place them in the comments section. And as always, stay safe and wash your hands.